Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Michael Feathers, who is a programmer, speaker, and director at R7K Research and Conveyance based in sunny California. You might know him as the author of the book, Working Effectively with Legacy Code. Michael Feathers, welcome to Maintainable.
Hi, nice to meet you.
In your published book, Working Effectively with Legacy Code, you wrote about how programmers often attach the label legacy code on other people's code, messy spaghetti code, etc., to which you offered a different definition. Could I get Michael Feathers on the record to share your working explanation of what legacy code is?
One of the things I basically said was that legacy code is code without tests. At least at the time that I was writing the book, I really felt it was an important message to get across to the industry. What I'd noticed is that essentially, when you have tests, basically there are a lot of things that are possible, with regard to refactoring the code base and work in a good deterministic way. So it seemed like it was important to go and get people to recognize that. So I thought, okay, rhetorical spin I can place on this is to go and just basically say, okay, look, there are conceptions of legacy code out there. There have been for decades in the industry. Why don't we just basically see legacy code as code without tests? And then at least you have a direction you can move in. If you get automated tests around your code base, then you're really in a much better position to be able to do the work. Without them, it's kind of like edit and pray programming, like hunt in there and just make a little tweak and hope that you haven't broken any.
Which I imagine you still encounter a lot of that in your field.
Yeah, I do. It's kind of amazing. Since the beginning of the Agile movement, we've kind of pushed, unit testing and things like that. It is getting better, but I quite often run into teams that have very low coverage. As a result, they really are scared of their code bases.
I know a lot of frameworks and tooling now, when I first got introduced to Ruby on Rails early on, and I know that you've worked a bit in that space as well. A lot of frameworks now include automated testing as kind of like something baked in the package. I wish it happened less often than I see it in my own field. So you open up an application and you look and you're like, nobody's been touching the test directory or the spec directory in a couple years. And it's I'm always curious about what triggers that, because it's they're giving you the tools, people aren't embracing them. And
I think it's the optionality of it, really. It's just the fact that essentially it feels like extra work for developers. And because it feels like extra work, then it becomes something that you sort of consider isn't quite necessary. When you have a job to do, you're kind of how do I get this job done, right? The easiest path to a solution is to just write code, right? And I think that's what we kind of recognize intuitively. But the biggest deal in software development is being able to do that sustainably over time. Writing the tests along with the code really helps with that, as I'm sure you know.
It's an interesting thing when I'm working with my own employee developers, they're not necessarily taught that earlier in their places that they've come from. It's not ingrained into their workflow. I've seen scenarios where people feel like that's an extra thing you could do, as you said, optional in some ways. But how do you know that your code that you've just written works?
I think there's a bit of ego involved also. It's kind of of course it works because I'm a good developer. Kind of and I thought hard about this, so how could I be wrong? And even though people don't really articulate these things, I think it's just something that's kind of it's just basic human frailty, right? That kind of thing. It's funny you mentioned this thing about it's one of those things that people just don't really think is quite necessary, or it's a sideline thing. I had this idea years ago I never really quite followed up on. I was working with a friend on a test-first IDE. We did it for Python, and of course never really released it. It was just a thing we were just kind of hacking together. But the idea behind this was almost if you know Eclipse or Smalltalk browsers, where you have a list box that shows all the classes and a list box that shows all the methods for a class when you select and stuff like that. And you just have a pane which has the code, right? What we were setting up in this IDE was that you couldn't actually create a method through the IDE except by going and typing in code for a test and then clicking on the name of a method. And then you get to the pane for the method. And it felt like that might be just enough of a nudge to get people to go and actually write the test first when they're doing their work. But, we got caught up with other things and never really quite released it. But I kind of wonder sometimes too whether tooling can help in these areas. Just get people to nudge to go and recognize that, hey, you should be thinking about the thing from the outside first, thinking about what the method is shaped like and writing code for the method, writing code that uses the method before writing the method itself. I'd love to see somebody pursue that deeper.
Yeah, that's interesting. I know that I've seen some things with some teams where they won't let the pull request go through unless they can see that there's been some test coverage modified in some capacity. And that's an interesting thing. And I think one of the things that I found from a lot of different teams and developers that I've talked to with other companies is that they might be coming into a project that has already had some foundation work there, and maybe testing wasn't embraced early on in the project because it was working towards some MVP or whatever, insert developer rationale, and for putting that off until later if it's necessary. And then since there's nothing to kind of build off of, it's like that's that blank slate in an existing application that's been running for 5-10 years in production and seems to be fairly stable, but you're like, I don't know exactly how to start testing this existing thing. And that becomes like, where do you start? And I know you touched on that a bit in your book. And what advice could you offer developers if they're in that type of scenario? Like, what's the first thing they could start doing?
First off, it's great if you're not the only person on the team who feels that way, right? So it's kind of like that thing of talking to your coworkers and, going and saying, maybe this isn't quite right. Maybe we need to go and do something a bit different. And then you're able to go and socially reinforce the work. Secondarily, a thing which I have in my book, I wish became more common knowledge in the industry, is that even in the oldest, cruddiest code base, you have opportunities to do new things, right? So in a Rails application, you'll be making new controllers periodically. You'll be making new models and stuff on those lines. When you're making new things, get test coverage around those things. That's way easier to do than trying to get coverage around existing things. And then you start to go and get this ethic on the team of like, this is what we do. We basically have tests around the code that we work on. I think that half of this really is getting people used to the assurance that they have, the feedback loop that they get by having these tests. I think it's kind of sad that still in the industry, there are a lot of developers who just never really had that experience of having your tests basically save your life when something goes wrong. You get that happen a couple of times and you're kind of like, why am I working without them? So I think that's really an important thing to go and get across. And when I do training and stuff, it's training and workshops and consulting. It's quite often about getting people to go and have that kind of visceral experience so that they can recognize that, wow, there's an answer.
Do you find that when you're coming into teams and you're helping them kind of see the light a little bit or help them, I would assume that's not always a scenario where it's just a group of developers that hasn't done any testing. It's just maybe that application it's not been prioritized or the team hasn't been able to get some momentum there. Do you find that there's some good patterns that help advocate that amongst your peers? If maybe you're really excited about this and you want to get some allies within the organization?
One of the things that I do every once in a while, and it really depends upon being with people a bit durationally, is helping them interpret their experience when things go wrong. You don't want to be the person who comes in and says, oh, you're doing this wrong. It's like, do things this way and things will be better, right? It's more like when things happen, you can kind of point out in a subtle way. It's like, oh, yeah, no, I saw that happen. It's like, well, in other scenarios, I would have perhaps written tests for this and we might not have had that particular issue. That's a very overt thing, I think the most important thing is getting people to concretely associate the pain of having bugs and having poor quality with the lack of doing some of these things. You have to be basically sensitive to how people are going to respond to you. So much is really about developing rapport with people and getting them to trust you and see that you're both there for the same goal, which is to make things better.
And that's an important point you're making there. Also, I wanted to congratulate you. While I was preparing for this, I saw that the 15th anniversary of your book being published is literally a week from today's recording.
I think technically, because the copyright date is probably next year, but by the number that's listed on the book, 15 years. Yeah.
Do you still think you'd be talking about this in 2019?
Well, the problem doesn't seem to be solved yet, right? So it's good. It's funny about this too, because I felt at the time that I wrote the book that it was a diversion for me, because I was basically spending a lot of time helping teams transition to Agile and design topics and stuff like that. And I thought, okay, well, I'll write the book, I'll get it out there, and then I can go off and do other things. But I think fate had other things in store for me. But I don't regret it, though. I think this is a problem that people confront all the time. And I'd like to basically see us do better at solving the problem. One thing that's happened, though, as a result of this is seeing lots of ugly code in the world. I've spent a lot of time thinking about how do we actually get into this state. I think there's a lot more that needs to be said in that area.
What do you believe developers often get wrong when they're discussing legacy code, when you come into teams and you're talking with them?
I think the main thing is feeling lack of agency around it, feeling that they don't really have any control over the situation. There are always things you can do to make your working environment a bit better. The thing that's kind of rough is that quite often when you're surrounded by crazy code, then it's kind of like it feels like the little things that you do to make things better are insignificant relative to the bigger picture. So I think there's an issue of focused attention with us here. I know with domain-driven design, for instance, Eric Evans quite often talks about the core part of the application, the computational core, that is the thing that everybody really depends upon within the business, and a lot of the other things are peripheral. And if you can find the areas of code that really are essential and go and sort of consider them to be something that deserves a bit of a higher standard than the rest of the code, then you can start to feel as you get tests in place and refactored, you've got a bit more control over those things.
Let's talk a little bit about code quality. So it's not just testing, but actually, the clean code. What do you believe are a few common traits of maintainable software outside of having test coverage?
Yeah. I think the main thing really is understandability, and everything just kind of flows from that, right? If you can look at a piece of code and understand what's going on with it, and then make the changes you need to make without feeling that you're climbing a mountain to go and get to that understanding, things are way better. A lot of the incremental process that we use to develop code kind of leads sometimes, if we're not careful, to this organic growth thing where you have like a branch off of a branch off of a branch, just like inside of a tree. That kind of thing really does get in the way of the simplicity that leads to understandability in code bases. As far as code quality itself, I really feel that we've done this big shift in the last, 5-10 years or so to speak very directly to the people issues we have on teams and how do we relate to each other at work and lots of things. And it's a conversation that needed to happen in the industry, but I also feel that sometimes we're just not taking the code seriously enough. That's really unfortunate because, the code impacts us too, right? I gave a talk earlier this year at a conference, and it was called Empathy is Code Deep. It was really all about this notion that we can talk about having empathy at work, but it's like, if you aren't writing code that's of a decent level of quality, it's not really empathy for your coworkers, right? It's like, you're doing this thing, you're putting this thing in the environment that's affecting your coworkers. Mm-hmm. So that raises the importance of that stuff. And we really need to go and sort of think in those terms, I think, as an industry.
In what ways are developers able to understand whether their code is of quality in a non-subjective way?
Non-subjective. I think there's this interesting thing with this that a lot of it comes down to having deeper understanding of design and also getting the experience of going and seeing some good code. When you talk about objective, like there are the solid design principles and various different things. And solid is just really the tip of the iceberg when it comes to a lot of the folk advice that we have within the industry about what good design is. Taking those things and internalizing them develops your design sense. Martin Fowler's refactoring book is great for this, by the way. It's like, I think when his first edition came out, somebody made the point that it's a great design book because it shows you a bad situation and shows you how to fix it, and then shows you what good design is by implication. So I don't think there's like a set of rules you can kind of like apply and say this is good design, but developing experience by going and reading and trying things out, discussing things with people really helps a lot.
Do you ever promote or use any code analysis type tools like code climate-esque applications to help companies and their team members understand quality?
If people already have those things in-house, then I kind of, say, sure, here, use these things. I don't really go around sort of advocating particular tools because everybody has different tools and stuff along those lines. We work with a bunch of different teams. It's kind of like I could become an expert in IntelliJ or Eclipse, but it's like I'd rather focus on the things which are, kind of independent of those tools. So yeah, I think the tools are great. I just don't really tend to focus on them very directly in my consulting.
How important is it for a team to remove code from an application?
I think it's very important. I had this experience early on in my career joining a team before I became a consultant, and we were working on this very interesting distributed lock structure for a distributed system. I was asked to basically do some work to optimize its performance. It was kind of interesting to basically notice after like 3 days of staring at the code, I realized that if one particular feature was removed, the multi-lock capability, then the entire thing could become much simpler and easier to go and sort of like optimize. And I went to another developer on the team and I said, we have this multi-lock capability. It's like, and I did a hunt through the code base and discovered nobody was actually using it at all. I said, if nobody's using this, can we just go and get rid of this feature? And he said, yeah, we just put it in there just in case somebody needed it. That was such a really foundational experience for me, wasting 3 days trying to understand something and then realizing later that it really was dead code. It wasn't being used by anybody at all. I tend to believe that code that isn't being used at all is like a lie in the code base. And for that reason, it really is very valuable to go and try to get rid of code like that as much as possible. I don't think there's really all that much tooling available for that. One thing that I've done with teams periodically is just set up logging, where you say, look, here's a code path I really feel is probably not being executed. So you put some kind of like a logging statement in, and then basically after like about a week or 2 weeks or something like that, you hunt to see if those logging statements have basically, arrived, in the log. If nothing's there, then you have a decent indication that this might be dead code. Of course, there's no guarantee. It really depends upon the dynamic paths that are traversed in the application. But even knowing that it's a frequently used branch of code can give you some feedback and help you.
I've seen a few tools, at least in the Ruby community, that's been helpful to try to track down what areas of code are being used and not being used. But I think there's always a little bit of nervousness if it's not a project you're consistently working on a regular basis. So I don't have a lot of the history there to know whether or not, well, maybe it's not being run in the last week or the last month, or maybe it's like some annual report they're using, those types of like rarely used features. And so that the worry about that, it's an interesting thing to try to figure out how to like identify, as you call it, dead code to hopefully remove it.
I think the biggest thing that really helps with that is really having a good relationship with the business, with the customer, and sort of talking to them about how much revenue is there really in this particular area of the business. Sometimes you can actually go and try to instrument these things very close to the user interface. And it's like you can say, well, look, if somebody has this particular thing checked, of course, we're going to take this path. And if nobody has that checked. But I think the big thing with that, too, is that when you discover something which looks like it might be dead, to go and sort of say, well, what's the alternative path here? And it's like, does that necessitate going and saying, we're going to take some of our customers and move them to this other thing rather than doing things one way, they're doing things another way, right? And those are all business decisions. So it really requires a lot of conversation with the business to start doing those things. The thing which is terrible is it doesn't seem like people prioritize this all that much because there's always like the train of new features that you want to have in an application, right? But I'd love to see more of an ethic around deleting code.
One of my developers was talking about how they were, over the weekend, they went to a friend's backyard forest to do some berry picking and apple picking. And they were talking about their friend had an apple tree that has 6 or 8 different varieties of apples that have been grafted on there. I was thinking about like how applications tend to be like that. Like, let's just keep grafting on things. But if there's stuff that's not being used or picked from the tree, do you remove that graft at some point?
Well, it's very interesting about this too, because one of the things that's been on my mind quite a bit recently is how we've scaled out development so much within the past, 10 years or something like that, but no longer than 10 years. I've been in the industry for a long time, right? But I remember like in the 90s, my first like real job in industry, I was developing a compiler for an in-house programming language. And I sat in a cubicle across from a guy who was writing an IDE by himself, for a company, right? And it's kind of like that solo work that we had in the very beginning was, you didn't really have anybody you could kind of like lean on and help you when you were in trouble, except, randomly. But we do such team-oriented practice today, and I think it's good. But I think that it's allowed us to go and create much larger systems, but then we often get into the situation where no one person really understands everything, right? Nobody goes and understands how everything kind of ties together. And then beyond that, having automated tests, even though it's a real boon to us, allows us to go and basically end up doing a lot of things that we just don't really understand, right? So it's kind of like the effect of our good tooling and practices that we end up having a little bit less understanding of what we're doing. I kind of wish that we weren't in that space in some way too. I think that we can maintain a lot of conceptual coherence if we keep things small, if we have smaller applications and stuff like that. But it's kind of hard to see whether that would ever tip back in the industry, whether there's some technological shift that would go and lead us to go and say, we can have very small applications that have only like 2 or 3 developers working on them at a time, and they can just kind of get to know intimately.
I've been wondering as well about some of that, but also just like, has the tooling made that we now have access to and most people are adopting, like, is that helping us as developers as much as we think it is or not? And do you feel like 15, 20 years ago, the tooling we had then versus now is making our lives better as programmers?
Well, on the one hand, I think there's the old thing that when electronic calculators first came out, people thought, oh no, people won't be able to do multiplication and division anymore. Let's use the calculator, right? So there's a certain sense in which certain skill atrophies because you basically have the advantage of something which augments you. I think the way that we kind of see this is just basically with the internet having like complete ease with going and discovering, any API we want to and getting help for anything. Prior to the internet, then essentially a lot of this stuff was kind of like you either had a book you could look it up in, or you basically learned how to go and sort of like store that all in your head and basically come back to arrive at things from first principles, right? So I think things are a lot better that way, but it's kind of like there's a certain thing that we're missing from that also. The other thing that I will say is it's one thing that's kind of stunning to me now is to basically see how many tools are involved in software development, how many frameworks, libraries, and tools. I was reading something I believe on Hacker News a couple of weeks ago. It was an outline of a person's like one-person shop. So they had like their own little product, but they were using about 15 tools, different frameworks, tools. And I thought, my God, it's a stunning distraction of attention to go and jump from tool to tool to tool like that.
Yeah, it can't be, especially if you're that small of a team. So it's interesting. I always sometimes hear of like small little startup companies where they only have 1, 2 developers working on a project, and they've invested a lot of time into building up this infrastructure for their application, for the health of the code and all those reasons. And then what have you delivered for your MVP at this point? And you're like, well, we got the infrastructure in place. We're ready to scale. And I'm like, do you have a product yet that actually sells yet or makes any money? We'll be back with my interview with Michael in just a moment. Hi, it's me, Robby. I want to thank you for listening to the Maintainable Software Podcast. If you're finding these conversations valuable, please consider sharing it amongst your peers and a writing review on Apple Podcasts to help spread the word. Thank you so much. Also, if you have a good story or two to share about ways to improve the long-term maintainability of software and might be interested in being a guest on the show, please get in touch with me at Robby with a Y at maintainable.fm. And now back to our interview with Michael Feathers. You had an article a couple weeks ago that you published called Socio-Technical Seeing, and I'll link to that in the show notes. Could you provide kind of a high-level overview of the thesis of that article?
Yeah, sure. It's kind of a weird personal thing in a way. I think one of the things that's really struck me being, in the industry for decades is that as much as we've been talking about Conway's Law recently within the industry, I think we really aren't going far enough with it. I think that when you take a very Conway's Law frame on the work that you're doing, you can often arrive at an understanding which helps you make better decisions in the context of your work. So what the article was about was basically going and outlining a scenario where there were several teams that basically decided that they needed a common tool, and they started developing the tool, but they didn't really have a team associated with the tool. In that, I was kind of like trying to go and outline the forces that are present in development when you have owned code and unowned code, and how that leads to basically like having pressure towards changing your teams. So it's really all kind of like an extension of Conway's Law. So Conway's Law was something that was observed by a guy named Mel Conway in 1968. He wrote a paper in which he basically made the observation that whenever you're doing design work, the structure of your thing that you produce is going to end up mirroring the structure of the teams that produce it. So if you have like 3 teams working on a product, chances are the code's going to kind of like segment itself into 3 different large sections, 3 different components. Quite often, if nobody's heard about this before, once you say it, they're kind of like, oh, I see that. I've seen that happen all the time in the context of my development. There's no real mystery about why this happens, really. It's like if you and I are on a separate team, like you mentioned you're in Portland, I'm in LA, right? If we're going to collaborate on something, it makes a little bit of sense for you to work on your thing and I work on my thing, and we develop an interface between us to go and actually have these 2 pieces of code integrate with each other, right? Or interact with each other. So geographical distance, human distance, all these things quite often lead us to develop APIs in the system, allowing us to do our separate work and then integrate it, with a nice interface. This within the industry, there's all different kinds of effects that you can kind of see if you're aware of this. One of them is like the thing that people have done for quite a while about having like feature teams. They kind of like rove around and basically touch many different areas of a code base, in a very large code base. That can work okay, but it can also lead to situations where without having any real sense of ownership, people are changing code that they don't quite understand, because of this effect that there are impacts in code based upon the way that you organize yourself as a team. And that doesn't mean that the opposite, having people in silos, is really necessarily better. If you have people in a silo working on a particular area, they can actually start to lose context and just only see the world through that particular piece of code they're working on. So having a siloed team versus a feature team, which one is best? I think that's really contextual. Some areas of code you might want to have a bit more ownership of, and others maybe not so much. But you only get to make those decisions when you're really aware of these Conway's Law effects. So yeah, that blog is really about that, and kind of like trying to open that conversation about. And it really comes right back down to this thing with legacy code, right? I've seen a lot of cruddy code. And I think that to the extent that we're aware of how we in process and in team organization affect code, we can make better decisions and try to, mitigate that slide towards the entropy hole, really.
What's one of the best lessons that you learned early on in your career that if you could plant that lesson in every upcoming and new developer, what would that be? Like if you could just plant it in their brain and be like, please just learn from me.
I think that the easy pat answer is how to get along with your coworkers, be an empathetic developer and everything along those lines. And I'm not going to repeat that because everybody else is repeating that in the industry. I think the thing that I found most important, though, is to chase the rabbit holes. Be way curious, right? If there's something you don't understand and you can take some time, try to investigate it, understand what's going on behind systems calls. understand how a compiler works. It's like if you're trying to fix a bug, understand the context around it. To the degree that we're really curious about things, we just basically develop all these new models, based upon the way existing things work. And those help us in design. I think for myself, my background is development, but I spend a lot of time thinking about many different things in the world, all kinds of systems, just trying to go and understand how systems in general work. Invariably, you're able to carry that stuff back into development. You can see something which basically works as a systemic construct in, say, sociology, and then try to map it to code. And that sometimes works, right? So being a deep systems thinker involves going and being really curious about systems of all kinds.
And do you have any upcoming projects that you're working on that you want to let people know about, or coming talks?
Well, I'm working on a second edition of the Legacy Codebook.
Oh, awesome.
So that's, with luck, will be out next year.
Will you be using different programming languages in this next version, or?
Yeah, I'll try to go and, add in like Go and Rust and a couple of the more, interesting, Swift languages. But I'll also be keeping a lot of the material that's there as well. I think there's a lot of things that I still notice people are kind of thrown by. So I don't want to go and like turn it into completely new material. But it will augment with a lot of things I've learned since the time that I wrote that book, as well as further insights into that thing of like, how did we get here? How can we frame development so that these things don't really happen?
If you could offer our audience, without knowing their code base, maybe they have a lot of technical debt and they have legacy code because they don't have any test coverage, or there's a bit of a mess there that they're working on a project right now. And if they had an extra half hour, an hour today to start moving things in the right direction, what would you encourage them to do?
I think so much depends upon developing your design sense and basically seeing better ways of doing things, right? So I think if you have a half an hour, I think the easy thing is to go and say, hey, extract some methods, do some things like that. Sometimes taking a chunk of code that you have and just trying to rewrite it, but rewrite it and not actually integrate it back into the code base. Kind of like in a scratch way. If you have a piece of code that has like 3 nested loops and it looks a bit crazy because it's mutating state in different ways, take a half an hour to go and say, how could I rewrite that basically like using collection operations? Stuff along those lines. You start to go and actually develop this repertoire of things which are a little bit more maintainable and understandable. I'd love for people to go and actually just like fix that particular piece, but it involves getting tests in place and stuff like that. I think so much of what's involved in getting better is seeing what better is. When we see what better is and we see what our options are, we're developing new code, then, we're better off. Of course, I don't want to basically sort of like say that and like not remind people that, by all means, try writing some tests, try doing some refactoring.
Some good advice there. So with that, a couple of last questions for you. What non-programming book do you find yourself recommending to people in your industry most often?
I think there's a lot of them, but they're all in very different areas. Yeah, there's one from the past that I kind of come back to all the time. It's called Turtles, Termites, and Traffic Jams. And it's not really a programming book, but it kind of ties into simulations and stuff along those lines. I think MIT Press, it's a little bit dated now, but it's still quite vital in what it kind of gets across. What it basically doesn't show is how rules and systems develop emergent behavior. There was this language called Logo that was basically designed for kids to use. Have you heard of Logo at all?
Yeah, I used it when I was a kid.
Yeah, very cool, right?
Yeah.
So in this book, they describe something called Star Logo, which is essentially language where instead of having one turtle, you have like thousands of them. And what you do is you set up certain rules. Like they have like this one simulation about termites picking up chips of wood. And so you basically go and set up rules for the termites. All the termites are basically going and using the same rules. And then you get to kind of predict what will the environment look like after these rules are applied over like many, many, many cycles. Starting to develop intuition about how rules and iteration basically go ahead and lead to emergent effects in systems is an extremely useful frame for people to have. I read that rather early in my career, and I think it kind of like led me down this path of going and like looking at, what are the little subtle things that happen when you behave this way at work, or when you do this particular thing in design, what are the run-on effects of those things? Because I think overall, just about everything that we do, every decision we make is a design decision. The way that we are at work, the things that we do in the code, how we design our process, those are all things that impact things at deep levels.
It's interesting. I'll definitely include a link to that for folks. And so I'm assuming with that, where you're talking about like the termites, when they're doing that, I'm guessing there's like rules that they can't kind of overlap over each other at the same time, or they have to try to find ways to create pathways without bumping into each other type of thing.
Simpler things like, okay, so just very quickly, there's kind of like, imagine like randomly scattered wood chips. You have a simple rule with the termites that essentially termite can run around randomly. Whenever it encounters a wood chip, it picks it up. If it's carrying it, when it moves around randomly, if it encounters another wood chip, it drops the one it already has. If you iterate that rule for a long time, what do you think happens in a random field of wood chips? So you basically build up like one giant pile, right? So that's a very simple case with it. It's kind of like this thing of like, basically trying to make the leap between the rules that we have and basically how that works with many, many agents and with lots and lots of iteration. It's a bit of a mind stretch for people quite often. It's cool you saw that like immediately, but it's like you can go further down that rabbit hole and it's like, how do we start to go and see these things? Yeah. I think at a certain level, we can't really see all the effects of the rules that we put in place with things, but at least going and developing a bit of caution around them, I think is kind of useful to go and recognize that sometimes when we put things in place, it's like it can become such a complicated edifice that, we shouldn't be surprised if crazy things happen after a period.
And where can people learn more about you and follow you online?
The main thing is Twitter. So it's just like mfeathers on Twitter. I have a blog. It's michael.feathers@silverback.com. There's no E in Silverback. It's just a blogging engine that I blog on, and I just have thoughts up there periodically. I speak at conferences. I'm at the Software Craftsmanship London conference next week and build stuff in Lithuania and Ukraine. And I usually go and post these things on Twitter, the conferences I'm going to.
Congratulations on the 15th anniversary of your book and looking forward to the second edition coming out. Maybe we'll have you back to talk about some of the new stuff that come up.
Sounds good.
It's been such a delight having you on Maintainable, Michael. Thanks for joining us.
Thank you so much.
Cheers. Maintainable.